Hello chemistry people, Amy here. As promised, today I'm doing an experiment looking at a gaseous equilibrium. I am not going to be doing as much talking as I do the experiment because I'm going to be using the fume cupboard and the sound quality is pretty bad when I try and speak and record my voice in the fume cupboard. So I'm going to be recording the experiment without sound and then dropping in a narration later on. So if you notice that my narration isn't quite in sync with what I'm doing, that's the reason. So I am going to cut my video now and insert in a description of the reaction I'm going to be carrying out and the equilibrium I'm going to be forming.
What I've got here is I'm going to do this reaction in two stages. Stage one is going to be reacting copper. Now, copper doesn't really react in metals. It's a very stable metal. So it doesn't react in the way that we would expect metals to react with acids, which we'll talk about in the acids and bases topic. So copper solid, you're probably familiar with it. It's that reddish, like pinkish gold metal. If I react that with super concentrated nitric acid, aqueous, it forms copper nitrate, aqueous, and 2NO2 gas and H2O liquid. It's 2H2O liquid. Okay, so the first thing I'm going to do is a quick little experiment where I just test out. I found some nitric acid up the back of the acid cupboard in the prep room. So I just want to double check that that is sufficiently concentrated. I will know that it's sufficiently concentrated if I start seeing a bluish solution. Remember, a lot of those copper compounds, like we saw in the last experiment, are blue. And I should also see some brownish gas start to be made. So I'm going to stop my little explanation now. And the next little experiment I do, I'm going to be mixing some copper and some nitric acid just to check that this is concentrated enough. Okay.
So for this first part, I'm just going to need nitric acid and copper turnings and also a beaker. So I take my beaker, add some copper turnings, and then pour in some 40% nitric acid. Now, it says 40%. I have no idea how long it was up the back of the acids cupboard, which is why I'm carrying out this test. So give it a swirl. And I'm putting my hand over the top of the beaker for reasons that I would like you to conjecture. And you can see that that solution, in even that very short amount of time, is starting to get that stereotypical copper blue colour.
So what that quick little trial did is it established that my nitric acid was concentrated enough to generate NO2 gas. The equilibrium that we are going to be looking at, and it really does assist if you've got decent colour vision with this. We are going to be looking at a gaseous equilibrium, looking at 2NO2 gas in an equilibrium with N2O4 gas. Okay, so What change am I looking for with this? My NO2 is a brown gas, whereas N2O4 is colourless. So I am looking for how pale or dark is my mixture. Is my mix. It's all about comparison. So as before, I am going to be having particularly when we get into temperatures, a control test tube. Okay.
So I am now ready to try my actual experiment. So I'm going to put some copper turnings into a conical flask. Then pour in my nitric acid. Oh, sorry, I'm going to use my leftovers from that little trial I did because I might as well use it as not. And then squirt in my nitric. I'm now adding a stopper with a delivery tube to the top, and you can see that that is generating gases quite quickly. Now, I tried to use like a jerry-rigged straw, but it wasn't working. So what I ended up doing, I'm going to end up flicking camera angles fairly soon, I think. I took off that straw and then used directly from my delivery tube into my test tube. You can see it's getting slightly yellow, but not quickly enough. So you can see there that I've removed that plastic straw and I'm just putting the gas directly from my delivery tube into that test tube. Now, NO2 is heavier than air, so I'm in a fume cupboard, but I'm able to just sort of pour the gas in, and you can see that brownish gas filling up that test tube fairly quickly. This isn't sped up at all. So I'm doing 4 test tubes just because it's always useful to do one extra, always over cater rather than under cater. So I'm just filling up those 4 test tubes with that brownish gas. And you can see that the solution in the bottom of that conical flask is that very stereotypical copper blue. Now I'm filling up a gas syringe with that brownish gas. I tried to get my phone camera to record it, but I was worried about breaking the gas syringe, so I didn't. I am in a fume cupboard. That is why I am not worried about letting that gas escape. So I'm not quite sure what happened there, why I tipped out that syringe and started again. But you can see that that is quite a distinct dark brownish colour. So I'm just going to pop that off to the side, pop that cylinder out of the way. And then I've got my 4 test tubes there. I think I've also got that angle on the phone camera later. That very stereotypical copper blue solution. And just tidying up a little bit. So all I've got here is I am demonstrating the colours of those test tubes that I filled up and my gas syringe. Okay, so I pushed down on my syringe and you can see all of that gas has just come straight out. Because of course it did. So just to see my failure from another angle. There you go. So what I ended up needing to do was to refill my syringe. Another reason I muted myself is that was quite frustrating and there were a few swears. So I'm just filling up my gas syringe, and of course that reaction is now no longer
energetic enough to just be pumping gas in. So what I ended up doing was I ended up topping up a little bit of copper, and I think I also added a bit more nitric, but you'll see that in just a minute. And again, you see that lovely blue copper colour. If you study HL chemistry with me, I will discuss in the periodicity topic why copper can be both blue and green, and the actual energetic process that leads to that. So there was a bit of shuffling about as I looked down and tried to work out a way that I could hold the syringe without the pink of my glove coming through underneath. So when I push in the syringe, we are looking for a change in colour. So let's talk through this again. I push in my syringe, it immediately gets darker, but then it becomes paler again without me changing the volume. Let's look at it a third time. Darker, paler. Okay, I might copy and slow down this clip just to make sure you can all see it. In this slow-mo clip, I want you to pay attention what happens to the colour when I depress the syringe, both immediately and after a second. And then what happens to the colour when I release the syringe, and again, immediately after that release, and then a few seconds later. Okay, so you can see there I've got my ice water on the left of screen and my hot water on the right of screen. I'm just getting a piece of white paper to act as a backdrop for us to make it a little bit clearer. It is difficult when you are playing with a set of chemicals inside a fume cupboard and you've got laptop set up. So I've grabbed those 3 test tubes. You can see that they are all roughly the same colour. I'm putting the left one in the ice and the right one in the hot water, and I've still got that control in the middle. So you can see that that reaction is very nearly instantaneous. You can see a distinct difference between my test tube on the left, which is in the cold water, and my test tube on the right, which is in the hot water. Now, of course, that blue test tube rack is in the way. So comparing the cold on the left to the room temperature on the right, the room temperature on the left, and then the hot on the right.
Okay, so thank you for watching that experiment video. So that marks the second of our experiment videos. I am planning on continuing this series for as long as we're in lockdown. So next week we'll be going on to acids and bases. Thank you so much. Let me know if you've had any trouble understanding this video, and I will try and make some changes for the future. Thank you so much. Have a fantastic rest of your day, and I will see you next time. Bye.